I want to begin this lesson by just reviewing quickly how to graph functions that are written in standard form. So you can see right here, this is not written in vertex form. I have no idea how to do my shifting to graph my vertex. So the first thing I need to do is compute my h using my formula. My b is going to be 8 and my a is 2, so I'm going to put those in the formula, and when I simplify I get -2. Once you have h, you're going to put that -2 in x's spot, and then you're going to simplify and get your k value. So now I know that my vertex is -2, -9. So I'm going to go ahead and graph that. And then from there we would use our counting pattern, and since there's a 2 in front, our counting pattern is going to double. So instead of 1, 1, it's 1, 2, and then 2, 4 is now 2, 8. And then I do have enough that I could do 3, 18. 3, 9 is now 3, 18. And that's how you get your nice pretty parabola. So far we've covered two forms in our unit. We've covered vertex form and we've covered standard form. All right, so in this first problem, we're at the point where we can look at that and say, okay, I go left 1, down 6, put a dot, that's where my vertex is, and then I know that's going to be a frowny face. All right, and I know that all because it's written in vertex form, so I can actually see the vertex. So again, left 1, down 6, upside down, boom, it's graphed. So vertex form is the best. It's super fast. We really like it. And then like the one we just did on the previous PowerPoint slide, we have one that's in standard form. So it's going to be a lot more work to graph. I cannot see how far to shift, left, right, up, or down. So I'm going to have to get h first, then I'm going to have to plug that in and get k, and that's when I get my vertex, once I have my h and k. So that's what we've covered so far. Today we have one more form, and this is that there's 3 forms in quadratic world. And the third is called intercept form. Now this is going to have 2 new letters in it, letters we have not used yet. So the formula is f of x equals a, parenthesis x minus p, x minus q. So we're going to go through and just specify what each of these letters, A, P, and Q, represent. It's nice to know what your letters stand for. So just like in standard and vertex form, A is just the number that's out front. It controls how high you go in your counting pattern. So if A is less than 1, that's going to make your parabola get wider. And when a parabola gets wider, the technical term for that is vertical shrink. So then in the opposite sense, if A is greater than 1, like 2 or 3 or 4, for example, your parabola is going to get skinnier. And that's called a vertical stretch. So the little role that A plays, that's not changing. So we're still going to have the same counting pattern roles. P and Q stand for x-intercepts. And I have a picture right here of what x-intercepts looks like. So it's where a graph crosses the x-axis. So with most parabolas, there's 2 of them because they come down and then they have to go back up. So they're going to cross through the x-axis twice. So the first x-intercept, we usually call that P, and the second one we call Q. Now these can be switched. You can call the first one Q and the second one P. Doesn't matter. There's 2 of them. As long as they both get named, we're good. So you could tell me P is -3 and Q is 1, or you could switch it. Q is -3 and P is 1. All right, so the next question is, if I give you intercept form, how are you going to graph it? You could graph the x-intercepts right away. That's about it. So there's a couple different ways to do it. And this actually, I'm sorry, this should be step number 1. So step 1, you're going to FOIL it all out. So I like to FOIL the parenthesis part first, and I'll handle the -2 later. So when I FOIL that, I should get x squared plus 2x plus 3. Then I'm going to distribute that -2 and then get my final answer. So if you notice, that looks like standard form. So anytime you FOIL something out, the resulting equation is standard form. So this puts us back in familiar territory, just like in our very beginning problem. Step 2 is I'm going to compute h using the formula -b over 2a. So I'll put my -4 in h's spot. I put my -2 in a's spot. I can't forget about an additional negative from the formula. and I simplify all that to get -1, so that's my h. Then we'll go ahead and we'll get our k by substituting that h value in for x. Now you actually have a choice. You can use this top form up here. You see how there's x's there? You could put that -1 in for your x's and then simplify that whole thing. Or you can use the standard form. So it does not matter, they're equivalent, they're just written differently. So if I plug my -1 into standard form, I would just need to be careful that I square first and then apply the -2. That's going to get you 8 for k. And then you guys know once you have your h and your k, you have your vertex. So we're going to go ahead and we're going to graph our vertex, and then we're going to use our counting patterns. Now when you do that, you want to make sure that you pay attention. It's supposed to be upside down and stretched by 2. So I'll go ahead and graph my vertex, -1, 8, and then I'll start using my counting patterns. 1, 2, 2, 8, 3, 18. Right, so you can see that our x-intercepts show themselves. When you use those counting patterns, you'll see those x-intercepts. So if I asked you to identify them, you would say p equals -3, that's one of them, and q equals 1. And again, those can be switched, it doesn't matter, but those are your two x-intercepts. So because these are all skills we've done before, I'm only going to run through 2 examples, but we're going to kind of do them simultaneously. So we're going to FOIL number 1 real quick. Okay, so we'll get x squared minus 2x minus 3. And then we're going to FOIL number 2 as well, while we're on that foiling kick. So I would first get x squared minus 6x plus 5, and then I have to distribute the 2 that was out front to all of that. So now I have standard form for both 1 and 2, and that's our familiar ground. We have worked with standard form. So we'll go ahead and run through our steps of getting h and then k. So h negative b over 2 times 1, which is 2, and that comes out to 1. And then over here we have -12, negative b over 2 times a, and that's going to get you +3. And again, when you get your k, you can put this one in either formula, whichever one you prefer. So I'm going to do 1 squared minus 2 times 1 minus, and I'm sorry, this should be a 3. We're going to fix that right now. And when we simplify that, we should get 1 minus 2, which is -1, minus 3, which is -4. So my k is going to be -4. And then I'll go ahead and get my k value over here. I'm going to put my 3 in for x. And when I simplify all of that, I should get -8. And then we go ahead and we graph it. So my vertex is 1, -4. We're going to go ahead and plot that real quick. And there's nothing out front of either form, doesn't matter. There's nothing out front, so normal counting patterns. 1, 1, 2, 4, and 3, 9. And we'll do the same thing here. So I'm going to plot my vertex, 3, -8. That's going to put me down here. Now there is a 2 out front. My a value is 2, so again, I have to stretch how high I go. So we have 1, 2, 2, 8. And then we can just barely fit 3, 18 on here, but we can make it work. That's going to be up to the very top. Right there. Right. So again, really nothing that new. It's just you FOIL and then you get h and k. That's the only difference, and that's it. That's all the forms.